Okay, so for this problem, it's asking for two side lengths and two angle measures that are going to be used throughout the whole entire problem. So I just decided to do side lengths of 15 and 20, and then angle measures of 25 degrees and 100 degrees. The first thing that it wants us to find is a triangle that would be solved using the law of sines. And so for that, I created a triangle with a 25-degree angle, and then with a side length right across from it being 15, and then an additional side length being 20. And the reason I knew that that was going to be law of sines is because in order for a problem to start with law of sines, you need to have an angle measure with a side length across from it, along with a one additional side length or angle measure. So I knew that this triangle was going to be solved using law of sines. Now next I had to make a triangle using law of cosines, and for that I did a triangle with a 100-degree angle, and then the side length to the left of it was 15, and then the one to the right of it was 20. And then I knew that in order for a triangle to start with the law of cosines, um, you couldn't have any like opposite angle, like you couldn't have the opposite side length of an angle, and the same with a side length, you couldn't have a side length with its opposite angle. And so this triangle fits that criteria, and so therefore it starts with the law of cosines. Now next was a triangle that I had to make that would have two solutions, and in order to do that, I had an angle measure of 25 degrees, the side length across from it being 15, and then the additional side length being 20. And I knew that in order to create a triangle to possibly have two solutions, I needed to create a triangle with a side angle case, which is shown on the screen. Um, and then I knew that it had two solutions, and when I solved it, I was able to get two solutions, which you'll be able to see the work later. And then finally, I had a triangle that had no solutions. And for that, I had an angle measure of 100 degrees, the side length across from it being 15, and then the other additional side length being 20. And I knew for a triangle to possibly have no solutions, I also needed to create a side angle triangle. And then I knew this triangle didn't have any solutions because when I solved it, I came to an untrue statement, which therefore meant there were no solutions. So next I had to solve one of my triangles, but before doing that, it's important to know like what the law of sines actually is. So what the law of sines states is that the sine over A over side length A is equal to the sine B over side B, which is equal to sine C over side C. So I decided I was going to solve the triangle that had two solutions. So my first step in solving that triangle was to set up my first sine equations. So that was sine 25 over 15 is equal to sine x over 20. And so the first thing that I did is I cross multiplied to get 20 sine 15, 20 sine 25 is equal to 15 sine x. And then I divided both sides by 15, and then I found the sine inverse of that to get the angle. So after doing the sine inverse of 20 times sine 25 divided by 15, I was able to get angle x to measure 34.3 degrees. And next, since we know that there's 180 degrees in the triangle, and we already have two angle measures, I was able to subtract 25 degrees and 34.3 degrees from 180 to get my y angle measure to equal 120.7 degrees. And so the next thing that I had to do was I needed to find the length of side z. And so in order to do that, I had to set up one more law of sines equation, which was sine 120.7 over z is equal to sine 25 over 15. And so after solving that, I was able to get side length z to equal 30.5. The last thing that I had to do to solve the first solution of this triangle was I had to find the area of the triangle. And in order to do that, I had to find the square root of half of the perimeter, and then I had to multiply that by half the perimeter minus each side length. So you can see that on the screen, what I plugged in to get that. And so after solving that, I got the area to equal 129.14. So I knew that since this was a side angle case, there was a possibility of it resulting in two triangles. And the way that two triangles would be created is the side of 15, that side length can swing in to create to another triangle. And in order to solve for the second triangle, I had to take the x value in the previous solution and subtract it from 180 degrees. So I did 180 degrees minus 34.3 degrees to get my new x angle to equal 145.7 degrees. And like I said, that accounts for the swinging in of the of side 15. And so next, since I had two angle measures already, I was able to subtract both of them from 180 degrees. So I did 180 degrees minus 25 degrees minus 145.7 degrees to get my y value to equal 9.3 degrees. And so next I had to use law of sines one more time in order to determine what side length z was. And so the law of sines that I set up was the sine of 9.3 over z is equal to sine 25 over 15. And after cross multiplying and dividing, I was able to get z to equal 5.7. And so just like in the last one, my last step in solving this was I had to find the area of the triangle, which was once again by taking the square root, and then in the square root you're taking half of the perimeter, and then you're multiplying that by half the perimeter minus each side length. And so after solving that, I got the area to equal 23.63.